Hello everyone, welcome to the lecture again. In the last lecture, we look at how to calculate the moment of a force about a given point O. Today, what we are going to do is we are going to learn how we find out the couple moment and reduce a force system to a force and a couple. So, let us start. Let us say we have many forces which are acting on a body. Okay. So, suppose I have a rigid body and on this rigid body there are many forces, let us say F1, F2, F3 and F4, and let us say we want to calculate the moment of these forces about a point O. Okay. So, how do we calculate the moment? From O we draw a vector R1, R2, R3 and R4, then total moment M, which will be sum or all the moments Mi. So, here it will be R1 cross F1 plus R2 cross F2 plus so on, and this can be generalized as sum over I Ri cross Fi. Now, note that here your Ri is the vector from the point O to any point on the line of action of Fi. Okay. So, it should be noted that it is any point on the line of action. Okay. Now, let us look at a situation where the forces are concurrent. Now, we already know the definition of the concurrent force. That means that all the forces they pass through a common point. So, again let us say I have a rigid body and all the forces that are there they pass through a common point here in, let us say, this point. And suppose we want to calculate the moment of this body about a point O. So, from O I draw a vector, let us say this vector is R, then the moment about O will be R cross Fi. Why there is common R? This R is common because it connects point O to all the forces. So, let us say this is F1, F2, F3 and F4, then R I can take outside and the sum of the forces. Now, we also know that the moment, so from here it is very clear that the moment or the torque is origin dependent. What do I mean by that? So, the comment is that moment or torque is origin dependent. So, that means that if you have a rigid body and let us say various forces are acting on it. So, let us say F1, F2 and F3, and you calculate the moment about O or you calculate the moment about O prime, then the moment about O will be different than the moment about O prime. Okay. Now, from here it is also clear that suppose I have a rigid body and you want to calculate the moment about this point O. So, you draw a line which is passing through O and the moment about this line or the moment about this line or the moment about this line will be the same because they are the same line which is passing through O. So, this tells us that the moment is a sliding vector. Okay. But note that the moment about this point will be different than the moment about this point. So, therefore, moment is not a free vector. So, that means it is a sliding vector, but it is not a free vector. Now, let us look at the special case where all the forces acting on the body is such that their sum is 0. That means that if the sum of the forces which are acting on the body is 0. So, let us say I have a rigid body and I want to calculate the moment about O prime, and the forces are such that their sum is 0. So, let us say this is force 1, this one is force 2 and this is force 3. So, what we do, from O you draw a vector on these forces. So, let us say this is R1, this is R2 and this is R3, then the moment about O will be sum over I Ri cross Fi. Now, let us say we want to calculate the moment about another point O prime, which is at a distance a from O. So, if you want to calculate the moment about O prime, then it will be, you have to draw the position vectors from point O to the force. So, therefore, this will be R1 prime, this will be R2 prime and it will be R3 prime. So, the moment about O prime will be sum over I Ri prime cross Fi. Now, you can take any triangle. So, for example, let us take this triangle. So, here you can say that vector A plus Ri prime, in this case it is R1 prime, equal to Ri, in this case it is R1. So, we can clearly see that A plus R1 prime equal to R1 and we have generalized it for any Ri. Okay. So, therefore, Ri minus Ri prime is equal to A. Okay. So, now we have the moment about O and we have the moment about O prime. Now, let us look at the difference between these moments. So, the moment about O minus the moment about O prime will be sum over I. So, we have to take the difference between this and that. So, it will be Ri minus Ri prime cross Fi. But just now we have seen that Ri minus Ri prime is A, which is the spacing between O and O prime. So, therefore, this will be equal to sum over I A cross Fi, but since A is constant, we can take outside the summation and we have assumed that the sum of the forces are such that they are equal to 0. So, therefore, this will be 0 since summation over I Fi equal to 0. What does this means? This means that under the case where the sum of the forces are 0, in that case the moment about O will be the moment about O prime. So, this implies that the moment become independent from the origin. So, therefore, the moment becomes independent from the origin. Now, let us see what is couple. So, first let me define couple. The moment produced by two equal opposite and non collinear forces is called a couple. Okay. Let us look at the example. Again, suppose I have a rigid body and there are two equal forces. So, let us say one force is this and the other force is this. So, these are two equal forces, they are opposite and they are non-collinear, that means they are not in the same line. Then the moment which will be produced by this kind of force, we will call it couple. Okay. So, to formulate the problem, let us say the spacing between them is d and let us say you want to calculate the moment about a point O. Okay. So, what do you do? From O you draw a perpendicular distance and let us say this is S and you calculate the moment about O. So, this force has a tendency to rotate about O in the clockwise direction. So, therefore, it will be negative and the tendency of this force about O has a tendency to rotate in the anti-clockwise. So, therefore, this will be positive. Let us calculate the moment of these two forces about O. So, the moment of these forces about O will be the first force multiplied by the distance, this is positive, minus the second force and the perpendicular distance from O and it will be S plus D. So, this is the moment about O and you can see that it comes out to be minus F times D. Okay. Or we can write down that the moment about O is just F D and it is in the clockwise direction. Okay. We can also get the same result if we take a position vector r and connect it to the line of action of the forces. Let us do it again by the vector notation. So, again let us say I have this rigid body and I have two forces F and F which are equal and opposite and let us say I want to calculate the moment about O. So, I draw a vector r1 to the line of action of this F and again I draw another vector r2 on the line of action of S and let us say this r is r2 minus r1. So, we can see that r1 plus r gives me r2 or r2 minus r1 is nothing but r. Okay. So, let us calculate the moment about O. So, moment about O is I have this force F which has the tendency to rotate in the clockwise direction. So, therefore, it will be minus r1 cross F plus r2 cross F and this can be written as r2 minus r1 cross F or r cross F. So, from here we can see that the point O has no consequence. So, basically this has a very big implication. We can see that point O has no consequence and the moment is independent from the moment center. Why is that? So, basically you have this rigid body, we have a couple. So, this is F, this is F, you calculate the moment about this point or you calculate the moment about that point or you calculate the moment about this point. In all the cases the moment will be same because moment is independent of their position, it only depends upon the spacing between them. Okay. So, from here it is also clear that couple is a free vector because you can place it any point inside the rigid body. Now, let us look at the resolution of a force into a force and a couple system. So, now we are going to see the resolution of a force into a force and a couple. Let us say I have a rigid body, and on this rigid body there are 2 points, let us say P2 and P1, and on P1 there is a force F acting. Okay. Suppose we want to move this force from P1 to point P2, and while maintaining the same external effect. Okay. So, let me write it down. If we have a force F acting on point P1 and we want to move this force on point P2 while maintaining the same external effect, then we can make use of the following steps. So, please follow it. So, we have a rigid body, and on this rigid body we have force which is acting at point P1. So, what we can do is at point P2, so this was the original system. At point P2 we can add two equal and opposite forces of magnitude F. Okay. So, this is like adding a 0 force at point P2. So, what we have done is we have add equal and opposite forces F at point P2. Okay. Now, you also know that this F and this F, they are equal, they are opposite, and they are non collinear force, therefore, they are going to make a couple. So, F and minus F, they make the couple, and let us replace them by a vector M, where M is the couple. So, this F and this F, I am replacing it by a couple. Now, couple is a free vector, I can place it anywhere. So, let me place it at point P2. So, now we are left with this force F and a couple, its value is M, and this is equal to one of the forces multiplied by the distance between them. Okay. So, let me mention here that this replacement of a force by an equivalent force couple system, and also its reverse procedure. It have many application in the study of mechanics, and we will use it later. Now, finally, let us look at the resultant of the force system. Let us say we have a rigid body, and again many forces are acting on it. So, let us say F1, F2, F3 and F4, and let us say we want to calculate the moment of this about a point P. This is some point which is convenient to us, and of course, it is arbitrary, but it is convenient. So, this is convenient arbitrary point. Okay. So, again the process is similar. You have this rigid body, and as I said, I want to calculate the moment at point P. So, at P we add equal and opposite forces. Okay. So, this is F1, this is F2, this is F3, this is F4, okay. And we also have the couple, because equal and opposite forces has make couple. So, at this point we also have couple M, and then at P we can find out the resultant force. So, let us say the resultant force is R, this is nothing but F1 plus F2 plus F3 plus F4 in this case, and we have the moment M. Then we can also account for this M by translating this resultant R from point P. So, let us say we translate it by a distance d, and by this we can also account for the moment M. So, let me just write down these quantities. So, M, for example here it will be F1 d1 plus F2 d2 plus F3 d3 plus F4 d4. I am not taking care of the sign here. So, it will be just sum over I Fi di. And what is the resultant R? Resultant R will be F1 plus F2 plus F3 plus F4, which is nothing but sum over I Fi. Now, how much I have to translate? So, I know that M, or the moment, is d times R. So, therefore, d will be M divided by R. Okay. So, let me stop here. Let us discuss couple of examples in the next class. Thank you.